Hi guys. All right, so the beautiful thing about these video notes, number one, you don't have to stare at me dancing across the classroom, and number two is that you can pause and rewind. Okay, please use these features. Normally in class you get the chance to ask questions, but because these examples are so detailed, this is what we have to resort to with our time, and that's okay. Also, as you're going through, make sure that you're writing down questions on your notes. Write them down on a post-it, write them down in a different color, highlight them, something so that when we come back to class on Monday, you know what questions you had. All right, so this first example, periods 2, 3, and 4 all got to a different place. I'm just going to start from the beginning. If you want to watch it again, great. If you want to fast forward to where we were in your specific class, totally fine. Okay, again, use this to your advantage. All right, here we go. So the first thing that you need to do is identify if there are any holes. And this is both the polynomials in the numerator and the denominator in standard form, so we need to factor. The numerator, you could factor out a -1 or leave it. Either one, it doesn't matter. Some classes we did, some classes we didn't. I'm just going to factor it out for the video. And then in the denominator, the greatest common factor is 2x squared. So we factor that out and we get x plus 2. Okay, so looking at the numerator and the denominator, there aren't any common factors. So we can say that there are no holes for this particular function. You cannot cancel out the 2x squareds. The one in the numerator is being subtracted by 1. So it's not a monomial, it is a binomial. So if you're going to take away from one of the terms, you have to take away from both. All right, second thing that we need to find is the vertical asymptote. That comes from what makes your function undefined. In this case, what makes our denominator equal to 0. So we're going to set both of the denominator pieces, both of the factors, whoops, I don't need that parenthesis, equal to 0 to find out what exactly or what values are going to do this, make our function undefined. Okay, so for the first one, if I divide by 2, we get x squared is equal to 0, so x is 0. And for the second one, x is equal to -2. So like I mentioned in class, I like to put my characteristics in one area because there's a lot going on. And I don't want to have to search through my work to find my vertical asymptotes and my horizontal and so forth. That's a strategy that works for me. If it works for you, great. If you find something else that works for you, awesome. Just find a system to where you can find your characteristics quickly and easily. All right, horizontal asymptotes. That was that chart that we saw. For those of you that are not actually remembering, it's this bad boy that we filled out yesterday. Okay, there's 3 different scenarios. So if I'm in standard form, I look at the greatest or highest exponent. So my degree of my numerator is 2, my degree of the denominator is 3, therefore the numerator is smaller than the denominator, and that means that the horizontal asymptote is y equals 0. Why? Because the denominator is getting exponentially larger while the numerator is not. So the fraction I should say, is getting closer and closer and closer and closer and closer to 0. All right. Some of us, this is as far as we got, so yay, new stuff. I think 4th period we got the furthest. Okay, so hang in there with me. And the x-intercept, we know that we solve that by plugging in 0 for y and then solving. Now for this, you can use either the given, if it's in standard form, or the factored form, it doesn't matter. When solving for x, you're trying to get 1x all by itself, or x is all in the numerator. In order to do that, we're going to have to multiply both the right side and the left side by the denominator. Okay, we can't solve if there are x's in the numerator and the denominator. So it cancels on the right hand side, but what happens on the left? Yes, it is just 0. So we get 0 is equal to -2x squared plus 1. So what does this mean to us? And some of us, we got here yesterday, some not. So think about it for a second. What does this mean? And if you'll remember, it means that we are only solving for x-intercepts with the numerator. This is going to happen every single time. Now you can go through the whole process if that doesn't make a whole lot of sense to you because you need to see it mathematically. That is fantastic. Or you can just solve the numerator. All right, so -2x squared plus 1 is equal to 0. I'm going to subtract 1 to both sides. I'm going to divide by a -2. And then I'm going to take the square root, and we need to remember that there is plus and minus square root of 1/2. Now that is not simplified because there's a radical in the denominator, but we have to graph this. So if we put square root of 1/2 into our calculator, you're going to find that it's approximately 0.7 if we round to the hundredths. So our x-intercepts are plus and minus 0.7, 0. All right, the y-intercept, we're gonna plug 0 in for x. So we get -2 times 0 quantity squared plus 1 all over 2 times 0 cubed plus 4 times 0 squared. Okay, in the numerator we end up with 1, in the denominator we end up with 0. So what happens there? It is now undefined. So is there a y-intercept? No! And that actually makes perfect sense because one of our vertical asymptotes is at the y-axis. And those are non-removable discontinuities. Your function can't exist at a vertical asymptote. All right, so we found all of the characteristics. Let's go ahead and plot them. No holes. We have a vertical asymptote at x equals 0, at x equals -2, a horizontal asymptote at y equals 0, and then 2 x-intercepts. Now wait a second, there are x-intercepts at our or on our horizontal asymptote. That is actually 100% okay. The only non-removable discontinuity is the vertical asymptote. So yeah, we can actually have a coordinate or a point on our horizontal asymptote. What's the purpose of the horizontal? The end behavior. It's not making our function undefined, it is guiding the end behavior. Okay, so what the heck? How do we find our function? Well, now we have to make a number line. And this number line, and this is new for all of you guys, this number line represents our x-axis. Okay, and we need to figure out what y values correspond to the different areas of our y-axis. So what hits the y-axis, or sorry, the x-axis? Our vertical asymptotes and our x-intercepts. So I have a vertical asymptote at -2, and then I have an x-intercept at -0.7, and a vertical asymptote at 0, and then another x-intercept. And I need to know, is my function above or below the x-axis to the left of my vertical asymptote, in between that of my vertical asymptote and the x-intercept and so forth? It might be helpful to actually draw what these are on your number line. Okay, so what we're going to do is we are going to take a test point. What is a number that is less than -2? There's an infinite amount. Let's say -3. And we're going to go back to the original, the given function, and we're going to test. Okay, so I'm going to say y is equal to -2 times -3 squared plus 1 all over 2 times -3 cubed plus 4 times -2 squared. Now it doesn't matter what the numerical value is, it matters what the sign is. Okay, so you could use your calculator, not opposed. We have -2 times 9 plus 1 all over 2 times -27 plus 4 times 4. Okay, it looks to me, if we have -18 plus 1 and then -54 plus 16, that both the numerator and the denominator are negative, which means this is going to be a positive. I'm going to be above my x-axis. All right, so the next section is between -2 and -0.7. So I'm going to choose -1. I have -2 times -1 squared plus 1 all over 2 times -1 cubed plus 4 times -1 squared. I'm checking the sign. What y values correspond to the x values being between -0.7 and -2? Okay, well, that means I have -2 plus 1 over -2 plus 4. That's going to be a negative 1 over 2. Ah, so this is negative. I'm going to put it below my number line so I know that that's where my function's going to exist. All right, for this next one, let's choose negative a half. Okay, because it has to be between 0 and negative 0.7. So y is equal to negative 2 and then negative a half squared plus 1 all over 2 times negative a half. Are we having fun yet? And don't lie and say you're not. Of course you are. This is fantastic. All right, so then that leaves us with negative 2 times 1/4. So we have negative a half plus 1 all over 2 times negative 1/8. So we have negative 1/4. And then 4 times negative 1/2 squared. So that's 1/4 plus 1. All right, that leaves us with a half over 3/4. Again, it doesn't matter what the numbers are. It matters the sign. This area, my y values are positive. All right, we've got 2 more areas to check. Yes, of course, you can use your calculator right now. Okay, so I'm going to use a positive 1/2. So y is equal to negative 2 times 1/2 squared plus 1 all over 2 times a positive 1/2 cubed plus 4 times 1/2 squared. All right, so negative 2 times 1/4 is negative 1/2 plus 1. All right, and then we end up with 1/4 plus 2. Again, it matters about the sign. Did I do this side wrong? I totally did. You guys, I'm so sorry. That should be a 2. Disregard that. I could erase it, but time is of the essence. Okay, there we go. So sorry. Oh, no, I was right. Oh my gosh. Yep, see, even when I'm not in front of you, I'm still a mess. Nothing changes. Okay, here we go. So that's 1/4, 1. Ay. So sorry. Okay, so then that should be 1. That was my mistake. And the sign is... what's the sign? Yes, it is positive again. Okay, so that means positive. Do me a favor and pause this. And then check that next section. And then once you have your value, come back and see if you're right. Okay, hopefully you paused it. Some of you are not the best at following directions. Yep, talking to you. Okay, so I chose 1. And it looks to me as if we've got negative 2 plus 1 all over 2 plus 4, that it's going to be a negative. Okay, here's why it matters. So now, gosh, we found all of the different characteristics, right? Pardon me. We found all of the different characteristics. And now we need to find what the graph's doing. Okay, to the left of our vertical asymptote, so this guy, we're positive. We know that our horizontal asymptote guides the end behavior. We also know that there isn't an x-intercept over here, so I'm not going to cross the horizontal asymptote. And I can't cross my vertical asymptote, so I'm going to have to shoot upwards as I get closer to the vertical asymptote. Why? Because I don't have an x-intercept. Okay, the second part between the vertical asymptote and the x-intercept, I am negative. So that means I have to start down, but I'm going to have to touch my x-intercept because it's a point that we found. And then, hey, I'm positive. So I'm going to go up, but I can't cross the vertical asymptote, nor do I have a y-intercept. All of these characteristics are guiding where our function goes. All right, the next section, is between 0 and 0.7, and we're positive, so we're above the x-axis. I can't cross that vertical asymptote, but I have an x-intercept. And then I go to the negative y values, so I'm going to go down. Now, I can't shoot down to negative infinity because the horizontal asymptote exists and it guides my end behavior. So I'm going to go below the x-axis, but I am going to come back up to it, and that's where I'm going to end. Aha! All right, last thing. Identify the domain and range. Well, if we look at this, that middle section goes from negative infinity to positive infinity. So that right away is going to state that our domain is all real numbers. Our range, however, has two vertical asymptotes. There are no holes, so we're going to say it's all real numbers. X can't equal, oopsies, let's go smallest to largest. X can't equal -2 or 0, because that is where our vertical asymptotes are. Or you can say negative infinity to -2, union, -2 to 0, union, and then 0 to infinity. And that would be the domain and range. Woohoo, sweet. That one's nice. I like that. All right, let's look at this one. Why? Because we have more. All right, so our second one, the top is in factored form. The bottom is in standard. So in order to see if there's a hole, because that's what we have to do first, I need to factor the denominator. 3x times the quantity of x minus 1 stays the same. I would highly recommend pausing this. Do not just jump to factored form with me. Give yourself the chance to try, and then press play when you have it factored. Okay, I did factor it already, so it's 2x plus 1 times x minus 3. So looking at that, I can automatically see that we don't have any holes, and I'm going to write it up here so I know where to look back to. Oh my. Okay, so no holes. The next thing to look for are our vertical asymptotes. That comes from the denominator. So I'm going to set both factors equal to 0 and solve. Just like the one we saw before, we're going to have two vertical asymptotes. This one at x equals -1/2, and then x equals 3. Again, I write everything in the same area so I know where to look when I start to graph. For the horizontal asymptotes, we have to look at the degree of the numerator. Okay, well, I have 2 x's, and this has an exponent of 1, as does this. So the degree of the numerator is 2. The degree of the denominator is also 2, and this one's in standard form, so it's really easy for us to see that they are exactly the same. Okay, let me erase this so we can get to the next part. And so if the degrees are exactly the same, that means we look at the leading coefficients. Okay, even though this is in factored form, you could multiply it out if you needed to see it. So that means our horizontal asymptote is going to be at y is equal to 3/2. When the degrees are the same, that means that you look at the leading coefficients of both the numerator and the denominator. If you forgot, look at the chart. Okay, so then that also means that there is no oblique, because again, our horizontal and obliques can't coexist. They come sort of from the same family in the sense that they guide your end behavior. Okay, next, our x-intercepts. We solve the numerator. So I'm going to say that 3x times x minus 1 is equal to 0. So 3x is equal to 0, as is x minus 1. Okay, remember, if I set this rational equation equal to 0, then I have to multiply both sides by the denominator to get rid of it. It goes away. 0 times anything is going to eliminate it, so that's why we solve the numerator. So x is 0 and x is 1. We have 2 x-intercepts. How exciting! Oh, so fascinating. I know, you guys are super loving this. You're welcome. Okay, and then for our y-intercept, we plug in 0 for x. Again, it doesn't matter what form you use. I'm going to go back to the original. 2 times 0 squared minus 5 times 0 minus 3. Okay, immediately I can see that my numerator is going to be 0, which means that my y-intercept is also 0, 0. Sweet. Okay, so we found all of those. Let's go ahead and sketch them all in, graph them all in. Oh, I feel like I'm going to sneeze, sorry. So our first vertical asymptote is at -1/2, and then we have one at x equals 3, and then y equals 3/2, and we have a point at 0, 0, and one at 1, 0. Very interesting. Curious. Okay, so now where does the function go? We have to draw a number line. The number line represents the x-axis. what interacts with the x-axis? Our first vertical asymptote, our next x-intercept, followed by another x-intercept, followed by our last vertical asymptote. We want to know, what are the y values in these regions? Where is our function? Is it above the x-axis or below? And then we're going to sketch it from there. I don't want you guys to find exact points. I want you to find the characteristics, sketch those, and then analyze what the graph is doing in each of the various regions. Okay, here we go. So the first one, to the left of -1/2, let's go ahead and use -1. I'm going to have y is equal to 3 times -1 times -1 minus 1, all over 2 times -1 squared minus 5 times -1 minus 3. Yes, use your calculator. The only thing that matters to me is what the signs are. Okay, I don't care what the numerical value is. It looks to me like this is 6/4, so that means that it is positive. Okay, go ahead and pause this video and find the rest of them. I'm going to pause and do it myself, and then you guys, pardon me, you guys can check from there. Okay, good luck. Welcome back. I hope you paused it and didn't just jump forward with me. Anyway, okay, so here's my sign chart. It's positive, negative, positive, negative, positive. What does that mean? It means I'm above the x-axis, below, above, below, above. Okay, so to the left of my vertical asymptote of x equals -1/2, I don't have any x-intercepts, and it says that I am above the x-axis. So I'm going to have end behavior by my horizontal asymptote, that is its function, and I can't cross a vertical asymptote, so I'm going to shoot up towards the vertical asymptote, but not cross it. All right, between x equals -1/2 and my x-intercept, this one's a little tricky. Okay, we're negative, so just get real close to that vertical asymptote. I'm going to have to touch the x-intercept. It's a point, okay, and it's a y-intercept. And then I go above it. Doesn't matter how high, you just have to be above it. We're not finding max and mins. Okay, we're sketching the behavior of the function. And then we cut through our x-intercept, and it says that we are negative, so we are below the x-axis. That last section to the right of x equals 3, it says we are positive, which means we are above the x-axis. I'm not going to cross it because I don't have an x-intercept. So I'm going to get real close to that vertical asymptote. And since the horizontal is guiding my end behavior, I'm going to curve out a little bit. And there it is. Now, for this type of graph, your domain and range is truly going to be built off of what you sketched. Okay, more so the range. Now, the domain is all real numbers except x can't equal, in this case, our vertical asymptotes because we don't have any holes. So I could say it can't equal -1/2 or 3. You can also say negative infinity to -1/2, union -1/2 to 3, union 3 to infinity. For the range, this is where it matters what you sketched, and it's all because of how high that middle section travels on your function. For me, I'm going to say that I go from -infinity up to 1, union. I then pick up at 3/2, comma, infinity. Neither one of my inclusion we'll say symbols, is a bracket because I don't get there. I'm going to get close, but I'm not going to actually get to that location. So for something like this, I'm going to base your domain and range, more specifically your range, off of what you've sketched. Make sure you look at your function and you know. Oh, so much fun. Look at us keep going. Oh, it's so good. All right, this one, I think it is funky not having x in the front. So I'm going to rewrite as x plus 3. Okay. Nothing I can factor, so right away I know that there aren't any holes. Boo. No holes. There is going to be a vertical asymptote because I do have something in the denominator with a variable, so I'm going to set that equal to 0, which means that x equals -3 is going to make my function undefined. That is going to be my vertical asymptote. Now, the degree of my numerator is 2. What's the degree of my denominator? Aha, it's a 1. So do we have a horizontal asymptote? No, we don't, because the degree of the numerator is 1 larger than that of the denominator. So we, ladies and gentlemen, are going to have an oblique. Yes, so excited. All right, in order to find it, we must take the numerator and divide it by the denominator. I am going to choose to use long division. Okay, that means we take 5x squared and divide it by x. It reduces to 5x, and then we multiply through. So 5x times x is 5x squared. 5x times 3 is 15x. And then, just like we would long divide numbers without variables, we subtract or change the signs. That's going to leave us with negative 15x, and bring down the next term, which is a 0. Start all over again. Negative 15x divided by x leaves us with negative 15, and multiply through. So we get negative 15x. Negative 15 times 3 is negative 45. If we continue to long divide, that means we're going to change the signs. And then these cancel, but we're left with 45, and 45 is our remainder. But we're not trying to figure out if x plus 3 is a factor of 5x squared. I don't care. I don't care if there's a remainder. I don't care if there is. What I care about is this guy. I want to know what equation is generated when the numerator is divided by the denominator. So again, I'm going to say we are not looking to see if the numerator holds the denominator as a factor. I don't care if it divides evenly. If there's a remainder, it doesn't matter to me. What matters is that, what matters is that there is an equation that's generated, okay? Very, very, very important, you guys. All right, x-intercepts comes from the numerator. So 0 is equal to 5x squared. X squared is equal to 0, so x is 0. So we have an x-intercept of 0, 0. And then for the y-intercept, I'm sure you can sort of guess at this point what it's going to be, but we'll just plug in 0 so we can see it. And it is 0 over 3. Yep, our y-intercept is going to be 0, 0 as well. All right, let's go ahead and sketch the characteristics. No holes, no problem. X equals negative 3 is our, oh my, come on, is our vertical asymptote. My pen doesn't want to work. There we go. We don't have a horizontal, but we have an oblique. Okay, so gosh, negative 15. I don't want to go down to negative 15. So I'm going to try and use my not my asymptote. Sorry, guys. I'm going to try and use my intercepts. Okay, so if I plug in 0 for y, I'll just do it over here so you guys can see what I'm doing. I'm trying to find my x and y intercepts so I can graph based off of that. Ooh, okay, there's one at 3, 0. Let's see. Oh, the y-intercept is negative 15. But I know the slope. So if it's up 5 and over 1, I can go up 1, 2, 3, 4, 5 and over 1. And then I can go down 1, 2, 3, 4, 5 and over 1. 2, 3, 4, 5. Oh my. I think we're going to have to extend this a little bit. Okay, so this is going to be my oblique asymptote. Yikes, we're going to have to extend it a lot. That's okay. Okay, so on your paper, make sure you guys go down and you extend it so you can see it. And then we have an x and a y intercept. All right, so we have our characteristics. We found them. We sketched them. We now, at this point, need to make our number line. The number line represents our x-axis. We need to plot all of our x-intercepts and our vertical asymptotes. I'm not thrilled with my spacing. Let me fix that. Because we want to know what are the y values doing in relation to anything that's intersecting the x-axis. Okay, we're not going to include any oblique asymptotes, okay? Just vertical asymptotes and intercepts, x-intercepts. The reason why we don't include the oblique is because its purpose is end behavior. Okay, so it'll guide the end of our function, but that's about it. All right, here we go. So a number that is less than -3 would be -4. We have y is equal to 5 times -4 squared over -4 plus 3. It doesn't matter what the number is. What matters is the sign. So if we have 80 over -1, right away I know that my y values, why do I feel like that's wrong? What did I do? Oh, no, it's not. Are going to be below the x-axis. Okay, for the next one, I'm going to check maybe -1. It doesn't matter what value you choose, you guys. What matters is that it's a number that's within that range. So we get 5 over 2. Okay, so if we're in between the x-intercept, and I'll sketch this in again, sorry, and the vertical asymptote, then we are above the x-axis. The last region we need to check is on the right-hand side, so maybe I do a +1. Okay, so we have 5 times 1 squared over 1 plus 3, and that is also positive. Interesting. See what I mean about we can't really tell what these functions are going to look like? We're going to do our best to sketch them based off of the characteristics and how we analyze. It's not like the reciprocal function, okay? All right, to the left, we are below of that vertical asymptote. We are below the x-axis, and there isn't an x-intercept, so that means I'm going to be, oops, I need to change colors. I'm going to have my end behavior by that oblique. I'm going to go up, and I need to shoot back down because I can't cross the vertical asymptote, and I don't have an x-intercept to the left of my vertical asymptote, so I'm stuck down below. Okay, and then between the vertical asymptote and the x and y intercept, I am positive, so I have to go through the point, but then I continue to be positive, so I'm going to shoot back up and end at my oblique. That is what that one is going to look like. Kind of crazy. All right, now the domain is restricted by a vertical asymptote, so it's all real numbers, but x cannot equal -3, or you can say -infinity to -3, union -3 to infinity. But your range is going to be something different. Now, it's harder to see because I'm not on the graph, but I know that I go from -infinity to about, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to approximate to, let's say, -14. Yeah, sure. And then I'm going to bracket 0 because I actually have a point at 0, so I know that I hit that location. Nice work, guys. Hang in there. We've only got 2 more. Hang in there. Whew, okay, we can do this. All right, so we need to first see if there is a whole. It's in standard form. What I mean by that are the polynomials in the numerator and the denominator are in standard form. And the numerator can factor. Greatest. It is a difference of squares. And what do we see, you guys? Yes, we see a common factor. Oh, that's great. So when we simplify, we're left with y equals x minus 2. We've seen this before. Okay, first we have to find the whole. Now we haven't done this before. We're going to take the canceled factor and set it equal to 0. X is equal to -2. Okay, that's the x value. We then take that and plug it into the simplified equation and solve. So we can see that our whole is at -2, -4. Right away, I'm going to plot that. So I'm going to go -2, 1, 2, 3, 4. There's my whole. Okay, so we have a whole at -2, -4. And what's left is a linear function, x minus 2. It's in slope-intercept form. Slope of 1, y-intercept of -2. They don't have vertical asymptotes, which makes sense. The denominator is 1. They don't have horizontal asymptotes, and they don't have oblique asymptotes. They do have an x-intercept, Okay, so we can solve for that. And we have to use, I mentioned this yesterday, but we have to use the, simplified form. So we're going to say that 0 is equal to x minus 2. So x is 2. And then the y-intercept we can just pull from the actual equation because, again, it's in slope-intercept form. So nice. I'm going to go ahead and plot those. So 0, negative 2, 2, 0. And since this is a line and you need a minimum of 2 points to create a line, I am simply going to take the whole and connect it to the intercepts. And then I'm going to extend down from the whole. And there's my function. So nice, right? Why weren't the previous 3 like that? They can't all be easy, guys. Sorry. All right, domain and range. All real numbers, because, oh, it's not. Those of you that caught that, good. It's not all real numbers because there is a whole. A whole is a removable discontinuity. So we're going to say all real numbers x can't equal negative 2. Be careful. We think linear functions, super easy. I've been graphing these since, I started algebra. But now we're throwing in wholes. So it's a little bit more to think about. The range, same thing. All real numbers, but y can't equal negative 4. Or negative infinity to negative 4 union negative 4 to infinity. Yes, a little bit simpler. I'll agree. But we have to watch out for the whole. Rad. Nice job, you guys. Okay, we've got one more. One more. We can totally do this. So here we go. All right. Linear factor in the numerator. Quadratic in the denominator. So we need to factor it to see if we have a whole. X minus 5 all over x minus, oh my Lanta. What do we see? Yes. And the students go wild. They're so excited. We can cancel a factor. Okay, so if we do that, we're left with 1 over x plus 3, which means we're going to have a whole. Let's find it. We need to take the canceled factor and set it equal to 0. So our whole is at x equals 5. We then need to take that and substitute it in to this simplified equation to find the corresponding y value. This is going to be so fun to graph. Our whole is at 5 1/8. Easy peasy. We got that. Now, I'm looking at this simplified equation and it looks super familiar to something we did 2 days ago. Anyone? Yes, ladies and gentlemen, this is a reciprocal function. And how do I know? Because I have a constant over a binomial. So we can follow those directions to graph it. Right away, I know that my vertical asymptote comes from the denominator. It's my h value, so x is negative 3. The horizontal asymptote, comes from the h value. But we can also look at the degree of the numerator, which is that guy. Yeah? X to the 0 is 1. That's why we don't write it. It's pointless. So the degree of the numerator is 0. The degree of the denominator is 1. The numerator's degree is smaller than that of the denominator. So y is 0. But we also have plus 0 on the outside. It's the k value. See how it all comes together? Pretty fantastic. Okay, so there's no oblique. We can absolutely solve for an x-intercept. So 0 equals 1 over, what's going to happen? Yeah, just like we've done with all the other rational functions, it cancels. We get 0 equals 1, which isn't true. So there isn't an x-intercept. Okay, for the y-intercept, plug in 0 for x. So we get 1/3. So our y-intercept is at 0, 1/3. Nice, you guys. Okay, let's go ahead and sketch these characteristics x equals -3, and then we'll do the transformation chart so we can get some practice with that as well. Y equals 0 is that horizontal asymptote. No x-intercept, but 0, 1/3 happens to be our y-intercept. And don't forget about the holes. So we've got 1, 2, 3, 4, 5, and then 1/8, really teeny tiny. Okay. Our transformation chart. We can say that A is 1. We can say that B is 1. We can say that X, we can say that H, is -3, and K is 0. So that means we have X minus 3 all over Y plus 0. If we have -2, -1/2, remember, I'm always going to write out the parent function points because it's easier for me if I already have them written out rather than trying to think about, oh man, what's the next one? Okay, make your life easier. So if I take -2 and substitute it in, I get -5. -1, you get -4. -1/2, you get -3.5. 1/2, you get -2.5. 1, -2, and then 2, -1. The y values are going to stay exactly the same because we don't have a vertical translation. We're not shifting up or down. So those all stay the same. Okay, the reason I'm able to use the transformation chart rather than the sign chart of our x-axis with the various, where is it? That guy, with the various characteristics is because this is a reciprocal function. How do we know? There's a constant in the numerator, a binomial in the denominator with a degree of 1. Okay, that's a dead giveaway. You're dealing with the reciprocal function. Okay, let's go ahead and graph it. So we have -5, 1, 2, 3, 4, 5, -1/2, -4, -1, and then -3.5, -2. And then we have -2.5, 2, -2, 1, -1, 1.5. Okay, now there's a couple things. We have found that there is a y-intercept, so I have to include it. We also found that there was a really teeny tiny hole, so you have to include it. Any characteristic that you find has to be shown on your graph. All right, domain, and we're almost there, is restricted by your asymptote and, anybody? Yes, your hole. Okay, the hole is discontinuous. So we can write it in set notation, which I just did, or we can say -∞ to -3 union, -3 to 5 union, 5 to infinity. Woohoo, that's a doozy, but so awesome. All right, range, we say all real numbers except y can't equal 0 and 1/8, because again, that's where our discontinuity lies. That's where that hole is, okay? Or you can say -∞ to 0 union, 0 to 1/8 union, 1/8 to infinity. Nice work. All right. You've seen 5 examples that are quite diverse. Remember to write down questions you have, highlight them, write them in a different color. We'll discuss them on Monday. Hopefully you got to the end of this video and you actually watched it, because some of you didn't watch the other one like I asked. Please, 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 you guys, give yourself the opportunity to practice. Practice these. The more you do, the easier it gets, all right? Have a fantastic weekend. I'll see you on Monday.